Have you ever actually looked at a map and thought of it as a piece of software? Probably not, right? We usually just think of maps as pictures of the world, static drawings on a piece of paper or a screen. But welcome to this explainer, where we're going to completely flip that perspective. Today we are reverse engineering the map. We're looking at it not as a picture, but as a carefully engineered psychological interface sitting right there between the physical environment and the human brain. Because when you look at a map, you're actually interacting with a highly complex system that's designed to manipulate exactly how you process geospatial data.
Okay, let's run through a quick system boot-up sequence. We've got 4 main parts today. First, the map as an interface. Second, designing for the user. Third, decoding cartographic tasks. And finally, the psychology of maps. Let's get into it.
Section 1. The map as an interface. So, what actually makes a good map?
Well, in the world of cartography and system design, we lean on the ISO 9241111 definition of usability. Think of a map's usability basically as a mathematical balancing act between effectiveness and efficiency. Effectiveness is all about correctness, right? Did you actually find the right gas station or did you end up lost in a cornfield? Efficiency, on the other hand, is your cost-benefit ratio, basically your time. If a map is 100% accurate but it takes you 10 solid minutes to decode it while you're driving, well, that interface has completely failed you. A highly usable map lets you extract the correct answer in the absolute minimum amount of time.
But here's the thing. Usability isn't the whole story. We really have to draw a sharp contrast between usability and user experience. Usability is cold, it's hard, it's analytical. Objective goals, correctness, time. User experience, though, that introduces the soft criteria. These are the emotional responses you get from using the map interface. Like, is the map aesthetically pleasing? Does it bring you joy? Do you inherently trust the data just because of the font choices or the branding of the publisher? You could have 2 maps that are equally efficient, but one might offer a far superior user experience just because it feels so much better to use.
Moving on to Section 2, Designing for the User. Let's talk about user-centered design.
The whole algorithmic linear process of user-centered design honestly reads a lot like a software development lifecycle. First step, you've got the analysis of users, where cartographers group users based on their prior knowledge or experience. Then, they define the requirements based on the specific tasks those exact users need to get done. Step 3 is the conception and design phase. That's where the interface is actually built. And finally, evaluation, where the map's performance gets rigorously empirically tested.
But the absolute secret sauce to this whole process? Iteration. Iteration is vital. A good map is literally never just built in one go. You have to test intermediate mock-ups empirically with real users. And the ultimate, absolute holy grail of this iterative process, which by the way is still incredibly challenging to pull off operationally today, is something called mapping on demand. Just imagine a system that captures your exact individual user profile in real time and instantly generates a custom-made map interface perfectly tuned to your specific brand and your immediate needs. That's the sci-fi future where this engineering is heading.
All right, Section 3, decoding cartographic tasks. Now, what's really interesting about this next concept is how we actually classify these tasks.
Let's conceptualize this using Macacheran and Crack's map use cube. Imagine a 3D space where all map tasks live. On one extreme, think of a TV weather map. The information is already known, the user is just the general public, the task is pure presentation, and there is absolutely zero interactivity. It sits tucked away right in the bottom corner of our cube. But on the complete opposite end of the spectrum, you have interactive data exploration. This is where you've got experts hunting for totally unknown patterns in massive datasets. Clicking, zooming, filtering, the whole 9 yards. The interface requirements for those 2 extremes are wildly, fundamentally different.
We can actually break tasks down even further, right down to the level of basic database queries, using Paquette's triad model. Essentially, every cartographic task involves 3 inputs: time, location, and theme. Usually, you input 2 of these, and the map outputs the third. For instance, if your inputs are the year 1970, that's the when, and the state of Bavaria, the where, the map processes those and outputs the what, which might be the population number. You are literally querying a visual database.
Let's move to a practical example and see how this builds out. The user inputs their search region, let's say Bavaria, down in the south of Germany. Their eyes scan the map to isolate that specific geometry. Then they read the graphical attribute value, like the size of a gray circle inside that region. The user's brain then transforms that graphical size into a numerical attribute value by cross-referencing it, and ultimately outputs the final answer, a population of under 18 million. It's just input, processing, output.
Which brings us to our final stop, Section 4, the psychology of maps. Let's zoom way in on cognition and perception.
Think of this entire process like a system architecture diagram, but for your mind. When you look at a map, a visual stimulus hits your eyes and travels through a very specific memory pipeline. It hits your sensory memory first, then it moves into your working memory through selective attention, and finally, it's continuously interacting with your long-term memory, retrieving old knowledge and storing away new facts.
That very first stage, the sensory memory, it is absolutely fascinating. It acts as a protective firewall. Because think about it. A map is usually this massive, chaotic explosion of colors, tangled lines, overlapping shapes. If your brain actually tried to consciously process every single pixel at once, you'd be completely overwhelmed. You'd probably short-circuit right on the spot. So your sensory memory filters the stimulus. Only a tiny fraction of what is actually on that paper or screen makes it past the firewall and into your conscious perception.
So the crucial point here is 3 to 4. That's the magic number. That is the exact number of information units or chunks that your working memory can handle at any given time. This ties directly into Sweller's cognitive load theory. Cartographers know for a fact that if they force you to hold more than 3 or 4 disparate variables in your head while looking at a map, your working memory simply crashes. You experience cognitive overload. This is exactly why looking at a really badly designed, cluttered tourist map instantly gives you a headache. Good maps group information logically so they don't overwhelm you with simultaneous, disconnected data points.
To offload all that stress on your working memory, the interface relies heavily on your long-term memory. When you look at a map and you see a blue line, you don't typically have to look down at the legend to figure out it's a river, right? Your working memory rapidly queries your long-term memory, recognizes the convention, and instantly decodes the symbol. This rapid retrieval via recognition is incredibly efficient. Recall, on the other hand, like forcing you to remember the exact location of a city on a totally blank map without any hints, that is computationally so much harder for your brain. And this brilliantly illustrates how this visual processing physically manifests in your eye movements. It is completely wild. When we read text, it's predictable, right? It's linear, left to right, jumping smoothly from word to word. But reading a map? Entirely different. It's spatial. It's totally chaotic. Your eyes are just darting back and forth from the map center to the legend, scanning shapes, following roads, constantly cross-referencing symbols.
We define this chaotic visual scanning through 2 distinct mechanisms: saccades and fixations. Saccades are these rapid, blind eye movements that can actually travel at up to 500 degrees per second. And here's the crazy part. During a saccade, your brain is actually taking in 0 information. You are effectively blind. It's only during fixations, when your gaze stops and stays completely stationary for over 200 milliseconds, that data is actually captured and downloaded into your working memory. So, designing a highly usable map means arranging elements, like, say, putting the title at the top and the legend close by, to specifically minimize the length of those blind saccades and maximize the efficiency of your fixations.
Ultimately, the whole shebang, the interfaces, the database queries, the saccades, the memory pipelines, it all results in a mental representation of geospatial knowledge constructed right inside your brain. We call this your internal cognitive map. So as we wrap up this explainer, I want to leave you with a question to ponder. Think about your own neighborhood for a second. How exactly is it coded in your brain? What specific details has your memory generalized? And what features really stand out? Because at the end of the day, the most complex, highly customized map interface in the world isn't sitting on your screen. It's the one operating right inside your own head.